This is the Average Guy Network, and you have found Cyber Frontiers, show number 10, recorded on October 13th, 2014. Here on Cyber Frontiers, we explore cybersecurity, big data, and the technologies that are shaping our future, all from an academic perspective. I'm your host, Jim Collison, broadcasting live from the Average Guy TV studios here in Bellevue, Nebraska, and we post the show with world-class show notes out at theaverageguy.tv. If you have questions, comments, or contributions, you can contact me if you'd like. Send us an email, jim@theaverageguy.tv. You can track me down on Twitter at jcollison. Or now you can call in those questions, 402-478-8450. I do have, Christian, I got a question from Kyle just for this show. We'll play it at the very end. I'll cue that up while you guys are talking.
Cool.
So, Kyle, thanks for calling those in. You can catch us live, catch us on YouTube after the fact, or catch us on Spreaker. All those things available at theaverageguy.tv live. Joining me tonight from a security fortification at Prince Frederick Hall that seemingly is on fire on the campus of the University of Maryland, College Park, Christian Johnson. Christian, how are you?
Hey, I'm doing all right. The fire drill was a little bit of an unexpected disruption to my podcast planning for the night, but fortunately it didn't drag into the 8 o'clock hour, the 8th hour of the past noon time frame. So looking forward to a good talk tonight, and I think we're going to kick it back with some cloud security and try not to get in the weeds too much and get a little bit philosophical in the cloud and see if that makes us more enlightened or not. I don't know.
Philosophical. This could go off the rails.
Could get serious.
And then literally the guy next door, Ashton Webster. Ashton, how are you?
I'm doing well.
Hey, I've heard Christian call you Ash a couple times. Do you prefer Ash or Ashton, or what do you like to be called?
What do you prefer? I don't have a preference. If you're gonna call me Ash, you should call me Ash Ketchum. No, I don't have a preference.
Either way, so Ashton's fine.
Yeah.
I don't know, when I think of Ash,
actually it's kind of weird because like my parents call me Ash, and like usually your parents are the only ones. Like if you have your name Christopher, you go by Chris with all your friends, they'll call you Christopher. My parents go the opposite way. They like drop off that last syllable because they're that
they took the short route.
I guess that's how they like it.
All right. Well, we'll call you Ashton. How's that sound?
That works for me.
All right, sounds good. And that's the same way. My mom calls me James mostly when I'm in trouble, and but Jim the rest of the time. So, all right, gentlemen, you said you want to get a little philosophical on us, a little bit of cloud security in the cloud, and Christian, let me throw it over to you.
Sure. So I think it's an important thing to talk about. We were thinking about show topics, and we're still working on our research lab project, and we're not at a demo point yet. So we want to take us a little step back. I've been doing a lot of research and work with cloud technologies on the enterprise side, and Ashton has had some exposure to that through his work too. So we thought we would try and intersect in the middle and just have a general conversation about cloud security and what those enterprise environments are looking like. And it's kind of I feel like a lot of people talk about, well, it's kind of a known quantity that there are a lot of people out on the internet talking about cloud. It seems like ever since 2008 became a year, everyone wants to talk about cloud. I feel like in some ways it's not, in my mind at least, cloud is not as big of a buzzword as what some of these newer ones seem to be, like Internet of Things. But there are actually new buzzwords coming out that are sub-buzzwords of the word cloud. So tonight we'll talk a little bit about these three new ones I have just kind of popped up out of nowhere: infrastructure as a service, platform as a service, and software as a service, which if you read in any order is SaaS, PaaS, and IaaS. So I mean, take that for what you will. But there's some,
I've never heard anyone pronounce those as that. But then again,
that's gonna make a blooper reel somewhere.
Yeah,
we are the bleeding edge.
Quite literally. So there's so much going on. So I want to start with Ashton actually tonight first, because he brought up some really interesting thoughts that I was not on my radar about how cloud computing is moving into containers, which a lot of people would be like, yeah, but what do you define a container as? And I have a definition of container. Ashton has a very different definition of container. So Ashton, why don't you start us off with that?
Yeah, I think when I mentioned this to Christian, or like when you kind of mention it to people in general, they're like, oh, I don't see how changing how I'm shipped my computer, like in what container it's in, I don't think that'll matter. That's not the physical container. We're talking about containers as sort of a parallel to virtual machines. So they're essentially what they are is they're let's talk about the virtual machines first. So normally what you do is you have your native operating system, and then the guest operating system that you install on this virtual machine has its own set of binaries and libraries, and those are specific. You can have multiple virtual machines. They each have their own binaries and libraries that they use. Now, containers are a little bit different. They're on a per application level instead of a per operating system level. So, for example, if you wanted to have one just general purpose, let's say web server that you could run on any operating system, that would be in a container. Whereas virtual machines have a different scope. They're the entire, they can host multiple applications at once. So the main difference in terms of the way that they're laid out is instead of having the binaries and libraries for each guest operating system, you have them shared among all the applications on this container instance. So that really cuts down on the time it takes to spin these up. In order of magnitudes from 10 to 100, they're considerably faster to spin up. So, for example, let's say it takes 10 minutes to partition the area for a virtual machine that you want to request on infrastructure as a service, or what's the other acronyms that Christian
PaaS and SaaS.
PaaS is what are they? They're software as a service and
software as a service and platform as a service, and really
so
containers kind of fall under platform, somewhere in between platform and software.
So a lot of times those will take sort of a more considerable amount of time to set up, whereas these application-specific Docker or container instances are really quick. And you heard there I kind of not slipped, but Docker is one of the main companies, and it's a company and also an open source project that is really big into these containers right now. And there's been a big push from a lot of companies like Google and other companies that have vested interest in having their applications run on any given operating system in these containers to push this research and open source project along more quickly. So that's one of the major things you'll hear is like, are these containers the virtual machine killers? Are these the people that are going to put VMware and companies like that out of business because they're so much quicker in terms of resources and so much quicker in terms of just setting them up? So there's a large community, and I think even the people that are somewhat against the security features, which I'll mention in a minute, are largely for them in the long run because they are just so much more efficient in terms of the resources because they share those binaries and libraries with the host operating system that they're running on, which really cuts down on the time it takes to use them. And that's something that helps not just for the end user who wants to quickly be able to use an arbitrary application regardless of their operating system, but also the development process doesn't have to be, the developers don't have to be concerned as much with maintaining their code with various different operating systems at the same time, which cuts down on the development cycle as well and leads to more agile development, if you'll let me use that buzzword. So it's got a lot of benefits. The security concerns that I mentioned are mostly in terms of the way that namespaces work, and those are basically the divisions of the processes and the libraries that the containers use as compared to the host operating system. And to be honest, these are still new, and there's not like 100% certainty, but there's concern that if there's overlap between those, or if there's a way to get around that, and in some cases there are, that you can gain control of the file system from within these containers. So instead of them being these perfectly sealed jails that we'd like to imagine they are, there are cases where theoretically you could escalate root privileges from within the container to root privileges without of the container, and from there you essentially have control of the system. On that note, it turns out, I didn't really know this at the time, I'm not sure if Christian did either, that last semester we both worked on a project, the honeypot project, we called it,
Right.
where we were given these honeypots. And I don't know if you're aware of this, but these were actually they were not actually virtual machines. They were in containers.
Right.
And I think part of the reason for that is that, like I said, they're kind of less expensive to set up. So what we did was essentially we tried to lure attackers on what's called the honey net, which is just this general network where a lot of attackers will scan IP addresses looking for vulnerabilities. And our goal was to attract some of them onto our container in this case. And the hope was that, obviously once they're on there, they can't get out of this little jail. It looks and feels just like a real operating system, but it's a little bit more lightweight. So obviously in that case, we had faith that they were not going to be able to get out of this container or jail that we had set up for them and get onto the file system, because in that case we would have some really dire consequences. But that's just one example of where you could use them. That's sort of a more rare example because it's actually emulating an entire virtual machine. Really, more commonly what you'll see is they'll use just for one application, like I said before. But it is possible to use more than one. They just aren't quite as capable of running all of those processes at once like a normal virtual machine is.
Yeah, and I mean, just to put that into context, OpenVZ still, it's a shared kernel architecture, but I believe it's still considered a hypervisor. So that hypervisor is still what is building that container. It's just that the kernel is shared between the physical host OS and its child containers, and that's in theory how, if you have an insecure kernel model in this architecture, one could escalate up to the next level. And so the alternatives to that, at least in the Linux world, if we're talking about technologies like OpenVZ is often compared and contrasted to Zen KVM, which is a very similar hypervisor technology, except it's not a shared kernel. So that one is a complete hypervisor and a separate, it's a self-sustaining virtual machine running on that hypervisor. So there's no real interaction of shared architecture between the two different, between kernels in the child system.
Yeah, and if you're more interested in the security considerations for the containers, Docker does have a pretty good article from their own blog about how they set up theirs to be, and I think Jim is going to drop it in the chat right now. But they have their own blog post on how they handle the security of them, and it's really interesting. They talk about namespaces, also C groups, and they even have dedicated. The containers don't have direct access to the network interfaces and things like that, so you can really control how much access these things have to a great extent. The main concern is just when they are at the kernel level, and it is theoretically possible to, once you escalate privileges inside, you have to kind of assume that it's possible to get out and be aware that that's a possibility.
Yeah, and I think, again, the container is interesting because I think that is a newer notion for if we're just talking about putting an application in that container as opposed to putting an operating system in that container. We've had putting an operating system in that container for a while. That's what OpenVZ is. But I think, more along the lines of what things are turning into is that the definition of container can also be just putting in an application. And to make a good reference to an interesting conversation point between myself and Paul Allen, who is obsessed with Project Ethereum, which is it's when I say it's kind of like Bitcoin, take that with a grain of salt, but that will help put your mind in the right place. But Project Ethereum is really about using the blockchain that is Bitcoin, where each transaction is, some encrypted exchange and token, and building a distributed, encrypted platform for distributed applications. So this is really interesting because Project Ethereum is purely contractual based, meaning that if I can write up a contract in code and there's a financial component to that, but there's also a component of, hey, this application lives in this space and it's distributed and encrypted throughout this platform that would be the world of computers that are connected to it, like Bitcoin is. Honestly, I'm not really like a huge fan of Bitcoin. I don't use it. I also am not. I think the blockchain is a very interesting notion, though. I think there's a lot to be said for theory and computer science with the blockchain in general. And while I'm not really sure, how good or bad Ethereum is going to do, they did manage to become the second largest crowdsourcing effort for its kind in history. I think they raised like 18 million on their opening offering for that crowdsourcing. So I mean, there's interest, but I think the takeaway is that we're now thinking about applications as being customer systems. And what do I mean by that? I mean, when I first think and approach this problem, I want to initially classify people who talk about cloud into two groups. The people who are cloud users, so people who like to go on AWS, maybe spin up a VM or a website or two, and the enterprise of developers and network engineers who are building these clouds and who are working with things like OpenStack and are trying to get their heads around implementing and designing these technologies. But really, it's fair to argue you should break down the users category into subparts, because I think we get a lot more meaning out of it when we say there are multiple types of users, and one of those types of users is the federal government. And there has been a lot of conversation around which model of what we call cloud computing is going to do it for all of the technology challenges we have in the federal government. And it came out, last week there was a pretty interesting article in GovTech, which I occasionally peruse, and it was this notion that we thought 3-4 years ago that one of the big answers to how the government could reduce costs in IT was to offload things to the cloud. And so when AWS started becoming a big thing that the enterprise wanted to leverage, the government was like, well, we don't really know or trust how to implement that into our secure environment. And so Amazon came up with something called GovCloud, which was a cloud designed specifically for federal government clients. And we thought that this process was going to be quicker than what it turned out to be. So, in 2011, the Office of Management Budget put out an initiative that basically said, we're going to modernize how we do IT in the federal government by cutting our data centers, flatlining our costs, and offloading things to the cloud. But we find in this day that really we aren't that far. Only 10% of agencies have migrated more than one half of their IT portfolios, which really shows that there's not a huge jump to say all of a sudden we're going to move all of our stuff over and shut down all of our data centers and stop paying for electricity. And it's kind of clear when you look at some of the other numbers from that article. Out of 286 executives surveyed, only 30% said that they were implementing cloud strategies, and of that, 58% were not aware that any cloud strategy was even underway at their agency. That's pretty staggering. In statistics, we would say 51% is a majority, right? So to say that 58 or 60% of federal agencies are identifying themselves as not really having any cohesive cloud strategy, that's pretty fascinating to me, because it's a huge topic in DC to be talking about how the federal government should be taking advantage of cloud. And I think this dilemma, which is very clear in the federal side, I think we could argue that there's other cases for it in enterprise and so forth, but I think this dilemma is what started the movement behind infrastructure as a service versus platform as a service versus software as a service. And not just that, but really what is now becoming called a hybrid cloud and a private cloud, where somehow we have the public cloud that we want to trust our data with communicates with our private cloud, and it becomes a hybrid. And I think that just shows you that even of those people who are willing to talk cloud in the government, they want a hybrid solution. They just don't want to let go of the reins that say, let's move everything off to a secure environment. This is a very interesting notion because we look at other things that are in the private commercial sector like Netflix. Netflix is a very strong example of how cloud is a huge success, right? Netflix is 45% of what internet traffic is going through our network pipes in the world. And not only that, but we are at a stage where all of Netflix is just, it lives in Amazon. And think of how many millions of customers Netflix services, and then think of just over a month ago when AWS had to reboot, I think, all of their machines because of one of the security bugs. Netflix was able to stay online. They had no downtime. Their customers were not impacted, and yet the whole environment in which they were being hosted on was being shut down in intervals. So just the fact, it shows the resilience of the platform, but it shows the economy of scale and the capability to scale. And I think that's a example to the federal government of, hey, there may be something to these models. Maybe you can comment on this, Ashton, even Jim, too, because it's a really, I think it should be relevant to everyone as a conversation point, and not just like the people in the weeds on the technology of how do we build a cloud. But I think there's a very evolving conversation around how do we build advanced cloud architectures. And I personally, out of the three categories of infrastructure, platform, and software all as a service, I resonate the most with infrastructure as a service because I directly translate that to OpenStack, which is the largest open source cloud initiative to build kind of like an AWS, but not, well, it functionally serves as AWS, but the technologies, I would argue, very different. But the notion of infrastructure of a service, which means the service we're offering is infrastructure. We offer compute, we offer storage, we offer network, we offer authentication, and that's infrastructure as a service. And I would argue AWS falls under that model. Platform as a service takes us up to the next level and says, we're not selling to the customer the infrastructure. We're managing and putting together the infrastructure to support a platform that allows them to onload and offload applications and automates the process of doing configuration, deployment, and management of those applications. And I think that's really relevant in communities that are saying, how do we cut our IT costs? Because they want to figure out, how can we move core business applications to the cloud that is cost efficient and lowers our costs of licensing and so forth. I think I don't know if I would put this under platform as a service, but it's what comes to mind, is the new Adobe Creative Cloud, right? So University of Maryland, all students have access to Terpware, which lets you get access to things that are licensed, so like Microsoft Windows, for example. We also get access to yearly based subscriptions of the Adobe Creative Suite. So I last year downloaded the whole Adobe CS6, but it was delivered to me as here's the application installer, go install it on your computer. Well, this year Adobe said, no, we're done doing that, and now they offer a cloud subscription. So you get you renew every year as a student 1 year of cloud subscription, and what it basically does is you connect to Adobe's cloud, and that cloud delivers the applications to your computer. So it's not quite this model where the application lives on the cloud, but we've already seen that with things like Microsoft Terminal Services, where we run applications on the cloud. And I think a good example of that is Office 365, right? We run Word, PowerPoint, Excel, and Outlook, which used to be applications that we just ran on our desktop, now are just solely running on cloud computing and cloud processing. And the idea is that, well, if I'm a rising IT organization or just a rising organization of any kind, and I need these types of services on the cheap, and I don't want to I don't have the money right now to hire an Exchange server administrator and build some farms that can run these services, I'll just pay for my organization, $100 a month to have, email and Office capability. And I think that's where platform as a service is strong, but we haven't really defined a technical specification for what platform as a service is. And this gets more confusing when we talk about software as a service, where now we're talking about not even just the application, but here's the licensing and delivery model. It's all subscription based and it's centrally hosted. That I think of more of Adobe, but again, it's being offloaded to the desktop, so it's a little bit strange. Jim, as an IT manager in Gallup, part of what Gallup's ongoing work is to make sure that all the internal technologies that Gallup uses is effectively supporting the organization while keeping our costs down. And that's part of what you and the team out at Omaha does. Is what type of technologies, if any, does this type of conversation resonate with what is going on in the workplace?
Yeah, I think when you talk about, particularly getting the software off the desktop, it has huge advantages, in the sense that not having to support a lot of that legacy software that comes with it, getting automatic patches rolled out and updates rolled out without the end user having to. We have problems all the time with folks where that stuff, patches and updates bog down, especially on Patch Tuesday, especially with Windows products. And so you have some of those needs. So yet at the same time, we have moved some of our applications up to the cloud in Amazon and such. And so we'd like to get from when you talk about platform as a service, I think we're pushing a lot of it that way too. And I think I think we're still doing it that way, is to gain scale, right? We can scale up very quickly in that kind of environment if we need to. If StrengthsFinder goes nuts, say one day President Obama comes out and says, hey, I took the StrengthsFinder and it changed my life, and you all should do that too, right? And we have to scale out very, very quickly. One of the promises is that we can add more, and add to the cloud, a lot faster. So I think as reducing costs, yeah, we talk about that, although cost reduction comes in the form of the opposite of Moore's law with that, right? It just gets, the longer you wait, it gets cheaper. Not really the opposite, but that is Moore's law. And so you get more for less in that case, but getting it out there, scalability, I think, is super important for us, and being able to move quickly in that cloud environment without necessarily having to bolt more things onto it.
Sure. And do you think long term, do you think cloud has longevity in terms of where our technology curve is going? Do you see this as a
Yeah, no doubt. I think we're Ashton, as you look at this, right? It's you guys, the two of you together, but Ashton, there is no other option than cloud going forward, right? You don't see a world where legacy stuff still exists, right?
Well, the cloud is another option now, and I think it's not ever going to go away for sure. But
I think it's the only way. It's going. Not that it's going to. This is a fad. I think the cloud. It's where everything goes, right? Eventually, we stop potentially doing stuff. There's whole big gigantic issues about where stuff lives from a data standpoint, right? This is the big hang up with cloud today. It's like, physically, where is this data being stored? And we're still not to the point where we can guarantee, like an Amazon can guarantee, that data is going to stay in a data center in a country where it needs to be. And data centers are still kind of limited. But I see a day when we don't even. It's archaic to think of on-premise, on-prem, your own servers. Why? Right? Why?
Yeah, primarily it does come down to sort of the security concern, and for the most part, and a lot of other things, it's fantastic in terms of the scalability when you need it. You can't really compete with that. Just being able to purchase more and immediately scale up is a fantastic opportunity. But like you said, when you don't know physically where your data is, I think that's primarily why the government has been slow to move to the cloud. I don't have a huge amount of experience in exactly what goes on there, but I have to imagine that's why that's the case. That being said, it doesn't have to be all cloud or no cloud.
No, I don't think it
doesn't
has
have to be a
be.
distinction. I think that for almost every company, there's going to be a certain amount of stuff that they say, all right, this is public, We can do this on an AWS instance, that's fine. But this information is more important. It's riskier to have that out there. This maybe needs to be a private cloud or on one of those legacy server rooms that you're talking about. But for the most part, that's a minimum, tends to be a smaller portion of the data than the type of stuff that you could put on these remote instances.
Right. I think we fix. I mean, it may take 25 years, but I think we fix the security. We figure all that security stuff out and get people comfortable with that. And then I think the days of having a private cloud, or it's still a public cloud. It's sliced off enough that you're comfortable enough that it's not sitting necessarily local in your data centers.
Yeah, and like you said, in some cases it actually does improve the security in terms of the patches that you aren't necessarily. The hope is that these patches are now automatically integrated in by the company that's hosting this for you, which in a lot of cases makes it more secure if you would be slower to do that, or at least more convenient if you are going to do it anyway.
Yeah, and Christian, wouldn't you say more resilient in that case because you're in a data center with multiple servers and the specialist, the specialty is there, that the chance it's going to be more secure in that environment where in a big data center?
Yeah, and I mean, I think
compute center. Right.
Sure, and one of the other words that I think has definitely been strengthened with cloud technologies, but I think was around arguably before cloud was really like a large part of IT is disaster resiliency and recovery, which IBM has offered as a service for a long time. And so basically what IBM used to do still does, and they basically build out a huge data center, and all it is they work with customers, big paying enterprise customers, to say, if our North Carolina office were to get wiped out, could IBM turn on all their switches to replace our network overnight so that our services and stuff is backed up, is running, is accessible? So, if a hurricane wipes out an IT compute data center of some kind in Louisiana, then IBM can say, oh, that's okay. We've replicated your environment down to the hardware level, the software. They literally will build replicas basically all the way on up and say, that's no problem. We have it running just as you have it over here at our data center up in Maryland in Bethesda. So that's like, in some ways, a very pricey way of doing things. But the cloud offers a lot of opportunities to scalably have that redundancy and that failover. But I think the argument is, what good is that if it's not secure, right? We can't, it's the cart before the horse. And, as of the last survey on how people felt about trust in cloud security, the answer is it's at an all-time low, actually. And that's, we can say, well, that's because of this thing that happened with AWS and with Rackspace, and and people are reading on their news feeds that there are all these nude celebrity photos coming out of the iCloud and out of the Snapchat and out of the cloud applications. And I think for the average person or for the average technology evangelist, that doesn't send good signals about where we are with IT security, and so or with cloud security. And I think one of the big conversations that is clearly happening based off these different cloud deployment models we've kind of conceived is we need to have bigger conversations about what is a standardized model for having a cloud architecture, right? Because we can say that's a defined thing, like, cloud architecture is, we'll do it like AWS did it, we'll do it like those guys. Well, I hate to break it to you, but you're not going to be able to replicate what AWS is doing. A lot of it's proprietary. But things like OpenStack, which provide an open source community for a bunch of people across the world to weigh in on what cloud should look like, even if you're not using OpenStack in your environment, which many people are in the enterprise and in government. They're using OpenStack now. But even if you're not using that, it's a very good way to study and do research about what the larger community thinks cloud should look like. And it also, the fact that so many people are interested in OpenStack, to me, signifies that a lot of people are also interested in building their own clouds. So I think that's a counter argument, which is that a lot of people say we want to offload things to the cloud, but there wouldn't be as much interest as there is in OpenStack if people weren't interested in building their own cloud. And that's shown by, we have 143 countries participating in the OpenStack Foundation. We have 19,000 developers on that project from top Fortune companies and global Fortune indexes. And it's already been, the 9th release has been out of the gate. Native support with the LTS, the 5-year extended support under Ubuntu. So I think it's very safe to say that we have not settled or resolved what it is we want the cloud to look like. And I think the open source community is battling that out. I think the proprietary cloud solutions like AWS, I think they're probably a little bit more comfortable, but I think the public may push them in one direction or another as they have. But notice how responsive AWS has been to what the economy is for cloud. So, when Hadoop started becoming a big thing, Amazon didn't kick back and say, "Cool, let it ride." No, they built their own service called Elastic MapReduce that used their cloud and provided literally a cloud offering of Hadoop, which they were arguably the first to do and did so very quickly, very efficiently. So, I think cloud providers and the model for what we want that technology specification to look like is still being driven in maybe 5 or 6 different directions that I can count, and that's going to have a big influence as we start to say, yeah, this model looks good. I don't think the enterprise is going to adopt this model really. And I think that'll help us kind of reach a consensus. The question is how long that's going to take. And I think the longer that argument rages on, the longer it's going to take for the federal government to get on board, because they're worried about the security, they're worried about the data integrity, and they're worried about how you deploy and sustain that from a technology perspective.
So where do you see this going? Let's say in 10 years, are we going to see a mass migration to the cloud? Do you think we'll have solved a lot of the problems in terms of resolving where the data lives and who's responsible for it if something is to happen to it? Do you think the government's going to get on board with this in the future, or are we going to still is this just sort of a fundamental problem with having the cloud computing is that there's an element of risk to it, and it's just not going to be all the way there?
Sure. I mean, I think.
So is this the norm, or is it going to get better? Is essentially what I'm saying.
Yeah. Well, sadly, I think it's a little bit of both. Look, the government needs cloud technologies, and they concede that cloud is eventually where it's where the curve is going, and they have to follow that curve. And this is a very similar argument to, well, virtual currency is really becoming a real technology, and we have not figured this out at the FDIC level, we have not figured this out at the Treasury level, but while we know government has not figured out how do we regulate virtual currencies like Bitcoin, we know that the technology that is virtual currencies is the way of the future. We can all acknowledge that pretty much, and I think that's a very early stage of adoption curve, right? Something like virtual currency. I think cloud is a couple years in front of that, at least. I would say maybe 4 or 5 years in front of that, where we acknowledge that cloud is a technology that's on the road for the future, but we also acknowledge it's kind of here now, right? And so there's concerted efforts in our hiring strategies, in our budgets, and in our development that suggest cloud needs to be an essential part. And I think what will end up happening is we will go through different iterations of cloud. So enterprise will adopt one platform, they'll hang out on it on a maybe a couple of years, 2 years, 4 years, depending on how big the organization is, and then they'll be like, well, this is yesterday's tech. Let's move to another cloud platform that's come out. And I think we're seeing that battle, right? After AWS popped up, Google popped up, IBM Bluemix popped up. IBM Bluemix, by the way, let me just tell you, is if you want an interesting hashtag to follow, go to Twitter and type in #Bluemix, because Bluemix, to me, it probably not to other circles, so this is personal, but to me, Bluemix came up out of nowhere. I mean, it was literally like there was zero conversation on Twitter about Bluemix, and then all of a sudden there was a community of multiple millions of people talking about hashtag Bluemix, and I'm like, well, what's a hashtag Bluemix? And that's really what IBM is starting to push in as their cloud strategy. IBM has a distinct advantage in the sense that now Watson is going into the cloud, so we're talking about bringing artificial intelligence into the cloud. No one else is talking about that, right? I think IBM uniquely is on that path of, hey, we're bringing AI into the cloud. What do you think of that?
What does that entail? Like what?
Well, it really entails bringing the power that is the IBM Watson machine into the cloud in such a way that people can use Watson like a service over the internet through the cloud. They can build applications on the cloud that are using the intellect and knowledge of Watson, which is a first. I mean, in comparison, the only thing I can think that even comes close is something like the Microsoft Azure machine learning service, which we talked about a couple of weeks ago. You know, machine learning is a component of what can make up artificial intelligence. But I think we all agree that Watson has achieved a unique level of, NLP plus train lost, NLP plus these plus machine learning plus semantic technologies plus big data. And Watson has really gone above and beyond what I think some skeptics had it projected for when it took out people in Jeopardy in 2011. So, I think part of what will push this adoption curve or this technology curve in one way or the other is going to be which services are the most attractive. So it's not just going to be about who's the most secure and who has the best infrastructure, but it's also going to be about what unique applications can I get on this cloud that I can't get on this other cloud. And I think IBM is onto something there where they're saying you can have AI in the cloud, but you can't do that on Azure. No, you just can't. So I think that's where we'll see some intersection between infrastructure as a service and platform as a service as playing a larger role in cloud.
And to that note, to bring this back to the containers discussion we had a little bit earlier, Google is now offering cloud services along with these built-in containers from Docker to run arbitrary applications on any operating system. So that's something that's coming along too, and it kind of brings us back to what you meant before, where, for example, with MapReduce, the Yahoo and Facebook and Google came up with their own versions of it and implemented those in their companies. And I think that's good, but I have to wonder if that hurts or helps the sort of open source component of these different technologies. So in terms of the containers, it's primarily been an open source effort to get these working, and that's great. A lot of times the challenges are there. It's not standardized. There's not necessarily the resources that they need to get the job done that would be offered by companies that are much larger, like Facebook and Yahoo and Google and things like that. And ultimately, I think it needs to be both. There needs to be these larger companies taking it under their wing because they're invested in this new technology in terms of both cloud and containers. And I don't know. Do you think that it hurts the open source component at all to have these big name companies get involved with this new research and kind of make it their own to a certain extent?
I mean, I think the open source community thrives on saying we can prove the proprietary is wrong, right? So yeah. I think that has to be there. I think that there's something to be said for that, the open source community is not going to be able to build Watson, right? A lot of man hours, a lot of finance went into that. So in some regards, I think that it's a safe thing to say that that's not really too big of a concern. But I think actually the open source community thrives by having that kind of competition to say we can do better by crowdsourcing.
Yeah, and I think it's always going to be there, and that's fantastic because we need that kind of crowdsourced energy in that makes it not a commercial interest, but like an interest in what's best for the individual and can also be used by the company without having it with restricted access to either of them. But then there's also security concerns in terms of that, where if it is an open source project, what kind of risk are you taking on by using it if it wasn't made with the resources that Google or Facebook might have there? And I think one example of that is with Heartbleed. That was an open source implementation of SSL, I believe, and there was kind of this like myth that there was a lot of people looking at it and reviewing it and testing it, but they still missed this bug that had been there for many months. So
yeah, I mean,
you kind of gotta have both there.
yeah, and I think too, though, one of the big things with open source is, well, OpenStack is millions of lines of code. How do we ensure that someone didn't, make one malicious line entry somewhere in those million lines of code? And so, OpenStack, I think, is, very excellent about, they have a dedicated security team that looks at these types of issues. They have a dedicated, they have a very extensive review process where it starts all the way at the blueprint level and works its way up till it's solid and ready for release. So it would be very hard for someone to do that, but I think it's fair to say that that possibility is always there, and that's a concern. The other big thing to point out is that enterprises will always favor, and many will always favor being able to say, Red Hat, if we pay you $500,000 for the support contract, then when we have a problem during our fiscal year or just during our year, you'll make it go away for us, and you'll put a team on it, and we don't have to worry about it. So I think those are two things to keep in mind when looking at, is open source really, where does the risk assessment fall? I think it's support. I think it's the potential, but the slim but potential opportunity for someone to insert malicious code, and who's gonna run and manage this thing. But I think on the converse of that is that if you're looking for a custom solution that you just can't quite get with anyone else, open source becomes your answer, because then you can take that source code and modify it to fit your needs and what you want out of it. So I think there's some trade-offs to be had for both sides.
Yeah, I mean, I don't think either of the approaches are going to go away, obviously. Like everything else we've discussed, it's just sort of an ongoing state for these types of projects. And they do kind of depend on each other. I like what's going on with companies. Apparently, OpenStack has a simpler process where they have a process they go through for acceptance of changes to the code and things like that. And also, I know I've mentioned that before, but Apache Software Foundation seems to provide a lot of the resources that smaller open source projects need to become fully fledged and mature coded projects. And I think that's really important, as well as having these big name companies sort of adopt the technologies and research and make them their own.
Yeah, no, for sure. And like I said, I think it's a combination of two, the company requirements are so different across the spectrum. Even just the size of your organization can have a big impact on, whether or not you have the funds to invest in people who are going to go out and implement the open source, or you're just going to put that money into, spin up a couple of VMs, let's call it a day.
So we talked a little bit about the enterprise and even federal considerations for moving into the cloud. In terms of the individual, let's say you're the average guy. Do you start to put your personal information on Dropbox now and start to say, all right, well, this is the thing to do. I'm gonna try and get all synced up with my cloud services, or do you think that there's going to be more of a push towards the private, homegrown cloud type services? I know there's options out there like OwnCloud, where maybe you buy a little home server or a drive, or you have an old computer that you're just going to leave on, and you use that as your little cloud. Do you think that's going to be the future, or do you think that these companies that are offering these services are going to kind of dominate in terms of that?
Yeah, I mean, I think, when we talk about something like Dropbox, right, people are already, that's just kind of a matter-of-fact thing, right, where we just, there are so many individuals who, they don't at a technological on a technology scale don't understand like, hey, what is, they understand, oh, Dropbox cloud, it's off my computer, but that's about it. So there's going to be a lot of people who keep using those types of services because they make it so easy, right?
Yeah.
Google,
It's the convenience, and
right.
that's I mean that's not just for individuals either. Right? To a certain extent, it's convenient for enterprises. It's convenient for whatever you may
Yeah,
be doing.
but I mean, convenience is one of the biggest things to sell cloud, right? If
Yeah.
you're AWS or you're IBM or you're Google, your mission is to make your services so easy and so convenient that you feel compelled to use those services. And that's the Google business model, is it not? Convenience, ease of use, and they turn that around based on how they can use your data. So
Yeah, but it is becoming more convenient to store your information in a private cloud. It doesn't quite have the mass appeal that these Dropboxes and Google Drives and what have you for public cloud services. But more and more, you're seeing things like I'm trying to think of the name of a lot of just like own cloud type services where you purchase the little drive that you can hook up to your router or whatever it may be that allows you to do this. And personally, I think that with the massive increase in the number of breaches that we have, from everything to Snapchat to the iCloud leak, there's going to be at least a small counterculture movement to sort of the homegrown cloud, private cloud type services. I mean, granted, right now, if you went around and said, how about that private cloud? I think about 99% of people would be like, that sounds kind of like an oxymoron. What is that? So it doesn't have the average guy appeal yet, but I would guess that if it continues to be an issue with personal information being disclosed in these breaches, with not knowing specifically where it is, and people just slowly becoming more and more aware of this whole thing called cybersecurity, I would at least kind of hope that there would be additional options and additional appeal for private cloud in your home, or personally for your own use, so you don't have to deal with that responsibility of keeping track of, you not really, just offsetting the responsibility of keeping track of where your information is.
Yep.
I'll agree with Carrie in the chat. I don't think there'll ever be a day when the private cloud is going to work. I mean, it works for some of us. That's the home server community that this all started out of. I mean, that was all our guys coming together, having our own private clouds, so to speak. And even back to Windows Home Server version 1, you could get access to that from the internet, and so that was a cool idea. But it's so difficult to implement for the average person that today it's just not feasible. People need to make it need to be drop dead simple. And I think what we see from the community today, especially the smart guys that are in the home storage market, is they won't move to the cloud. They're anti-cloud until it gets secure. And so until we have point-to-point security and every piece of data in the cloud is secured with your own private key or whatever that means, right?
Yeah.
It's not going to get mainstream until that happens. Now, ironically, we'll have the public uploading stuff to Dropbox unsecure in the clear. They'll do it in droves, which they shouldn't. There'll be enough breaches that I think the average guy will wise up and go, okay, we have to have some kind of security, and it will force those security companies, those cloud companies, into providing this kind of point-to-point or end-to-end security model. I think we're maybe a decade or 5 to 10 years from that being a reality. Maybe not. I'm seeing a lot of these cloud companies, cloud storage particularly, start to offer more encryption. So that's, think of even the new iPhone, right? Apple can't even crack it, right? Allegedly, right? So, it's one of those kinds of things. I think we're getting there, but it's going to take a while in complete security before everybody jumps on board and goes, okay, I can trust my data. Just was going through a Home Server Show forums thread today, and guys are like, I'll never go to the cloud because it's not secure enough for my data. Put anything up there that you don't want, that you don't mind if people are staring at it in open view. okay, so that's still, I'm not that crazy. I put all kinds of stuff up there. In fact, I put my podcast in the cloud hoping someone will crack it and look at them. It's a little joke there. But so I think we're a ways away from public, but I think we're closer than we've been. I mean, people are getting it. Like listening to podcasts, people are starting to figure that out. I just don't think, I think we're still 5 or more years away from it being totally secure.
Well, like you said, it's about making it convenient. I think, and I do think that's the thing that's blocking from people having the private option. I would imagine down the road, if there could be a company that says, just plug this in, it'll work right out of the box. You don't have to go to the command line or anything. I'd like to think there's a market for that, but maybe not. Maybe even that would be too much, and it's just like hard to wrap your head around.
Western Digital has tried that, right? They've got these plug-in,
that's what it was, yeah.
And it still doesn't. It's still people think that's still kind of weird. I think the average consumer still goes, "We get that," but the average consumer goes, "What? Can I just do it like Dropbox?"
And to be fair, if you're the average guy, maybe you can go out and buy one of those for, I don't know, $100, whatever it may be, or you can set up your Google Drive or your Dropbox for free in 5 minutes and have that sync and not have to think about it. Granted, that's only 5 gigabytes instead of a terabyte or something like that, but it's still, most people are like, well, what do I have that's that big anyway?
Yeah. Well, and let's be honest, like nothing is secure. Even your own private cloud, unless you disconnect it from the internet.
Yeah. Well, if you don't use it and you just like lock it away.
Yeah. And then what good is it? So. And there's applications for that.
Hence cybersecurity.
Yeah. Right on. That's why we're going to pay you guys a lot of money someday.
Yep.
All right. What else?
And I think that's I don't know. I feel like that's a fluffy graph on cloud, don't you?
Did we get to the end of the internet?
I mean, I think that's like the tape just runs out and you can't record anymore. Maybe we should do a deep dive into what the heck is OpenStack and actually break down what each individual piece of a cloud looks like, so people actually understand what a cloud is beyond it's a thing in our atmosphere that condenses water vapor.
It's a really tough thing to visualize. Let's be honest.
Yeah.
What do you think of?
Right. Well, you mean like real clouds, right? I think of 3 things: compute, networking, storage. That's all the cloud is. It's compute, networking, storage. And arguably, if we really want to get saucy, authentication. Those 4 things are the cloud. Compute, it means that you can distribute and spread virtual machines, containers, applications, zeros and ones across an infrastructure, and you can orchestrate that, meaning that you can schedule these activities of VMs being created, destroyed, suspended, shut down, rebooted, etc. Right? That's compute. So we like that. That's like supercomputers like the Pleiades at NASA Ames and whatever, IBM's Watson. Those are examples of compute, right? A lot of CPUs, lots of parallel processing. We're talking on the order of tens of thousands of CPU cores, maybe comprising just one data center. And making all of that hardware provide these abilities to schedule computation, scheduling computation to take place. That's compute. Then we look at networking. Networking, as the most broadest definition for cloud, is very simple. It is the infrastructure and the pathways in which allow both the internal system that comprises the cloud and the external internet that allows people to interface with the cloud to communicate with one another, and to do so in a high performance way that allows for different types and varieties of workflows, different types of network communication protocols, and provides the security of secure networking and the flexibility of having different routes go different places. That's networking. Both of these are core essential services that if you don't run rock solidly, you don't have a cloud. The third, obviously, which the average guy resonates with the most, is storage. the ability to store massive, massive quantities of data or just small data sets, the ability to say, I want 10 gigabytes of storage for my music files, or I want 10 petabytes of storage to store atmospheric science data sets. It's the ability to say, I want a formatted file system versus I want block storage, which just allows me to store random objects in almost like a heap if we're talking about software programming structures. And it's more importantly, storage is the ability to attach data to the network in which it transports it between the cloud data center and the user. You can't have storage without the network. It's very arguable you can have storage without the computation, right? You need very minimal computation to store electrons on a platter that can spin up and spin down. For example, AWS's S3 storage service, I think they call it, it's been a while, it's something Glacier. Glacier is literally, you send us a tape drive, we put it on our storage device, right? That's a U.S. Postal Service way of doing, network transport of that data. But it shows you didn't need to do a computation to store that data. Really, there really is very minimal involved. The fourth is authentication. We have to know that the users who are using these systems, whether they're administrators or whether they're users, are in fact who they say they are. And if we don't have incredibly strong authentication, the trust model that is cloud security entirely breaks down. And people won't have the level of confidence they need to use any one of those number of services. And those four core pillars as a whole, working together in harmony, like OpenStack does, is what comprises a functional working cloud from an infrastructure as a service level. And then to go and above and beyond that is where you start doing your new levels of abstraction.
I feel wiser.
There you go. That's the podcast right there. They don't have to do one in that now.
That's all, folks.
All right. Well, we made it through the hour, and we want to thank those who came out and listened to us. We made it all the way through number 10, which is awesome, and some great content, some great conversation here in this one around cloud and what that really means. And so if you didn't get it all, that's okay. Just go back to the beginning, listen to it again. You'll pick up on it the second time. We'll include some great links to a lot of things that both Christian and Ashton referred. They'll be in the show notes if you head out to theaverageguy.tv / in this case CF for Cyber Frontiers 101, and that'll get you directly there. Or you can head out to theaverageguy.tv and search just for 010, although that'll get you home tech 0102. So just do what I said the first time. And we want to remind you, as always, too, if you like to support the podcast in some way, we have a tech scholarship fund. In fact, Ashton is supporting a boom arm and microphone purchased by the here. Hold on, we'll cut over to you, Ashton. Show us that beautiful microphone and boom arm, which he smacked right in the middle of the podcast, which was fun.
I'm sorry. Yeah, I was trying to avoid it, but it's here.
It is. It's right there. You need to, and it's hanging off of a drawer still, right over there.
It is. Yeah.
Very nice. Well,
Yeah.
And that stuff purchased by the Tech Scholarship Fund, you can take advantage of that just by using the Amazon affiliate link, theaverageguy.tv / Amazon, or if you're in Canada, use theaverageguy.tv / Amazon CA. And that'll get you. We actually have a guy in Canada that will benefit, and he'll hack on some equipment to make it better, and that will benefit the whole tech community here at the Average Guy .tv. And then one reminder: if you're new to the podcast and you haven't subscribed yet, we'd love to have you do that. We have a great subscription page, and actually, we just got on iHeartRadio today. I got a notification. You can't, if you search for it right now, it won't come up yet, but in the next 24, 48 hours, it'll show up on iHeartRadio. And you can head out to theaverageguy.tv / subscribe. But it's available just on about everything, and we have a video large and a video small if you want to download those and watch them on your phone. We'll thank MediaFire. Speaking of cloud, we'll thank MediaFire hosting their cloud storage for us, for hosting those video large and small. We'll do it all again in 2 weeks on Monday. Let's see what that day will be. It's weird to have to do this 2 weeks ahead of time, but that's the 27th of October. Is that going to work for you guys, do you think?
Works for me.
Should be pretty good.
We're
And
prepping for Halloween.
Yeah, for sure. We'll do something spooky, I guess.
There you go.
And we should also make sure to take Kyle's question before we wrap it up for tonight.
Oh yeah, you know what? I went back and listened to it, and it had something to do with something completely different. So
Solid. Super solid.
we'll do that on Home Gadget Geeks coming up. It's more of a he was wanting to ask how I thought it was for this show, but he was wanting to know how on a single mobile device to listen to the show and enjoy the chat room at the same time. And I can walk through that. We'll do that on Home Gadget Geeks. I think, Christian, we have Uptime Robot coming up this Thursday. They're in the schedule, so maybe you can join us because I know that was you originally that found those guys, and they're in Israel, I think, and so the time difference is a little severe for them. I think it's 3 or 4 in the morning by the time they're up. But I'm clearing that with an email with them today, and so join us if you haven't joined us. Got a great tech community going on over at Home Gadget Geeks. Again, all part of the network. You can find that all at TV/live. We'll be back in 2 weeks, Monday, back to the regular time, I think 8 p.m. 8 p.m. Central. And we'll say thanks for coming out tonight. Thanks, everyone.
Thanks, everyone. Good night.
See you guys.